This lesson is about current. It's the first lesson in the electricity topic in GCSE physics. Now you may have heard of this word, this concept, current, before. Now before we delve into this topic of electricity, we need to go back to chemistry and look at metallic bonding. The reason why we need to do this is because circuits use metallic and often copper wires, and therefore the structure of metals like copper directly relates to the topic of electricity. Think back, pause the video, look over your notes if you have to. How do you describe metallic bonding? So, based on the video, you should be able to identify that there are two parts to the structure. The first is that it's a giant lattice of closely packed positive ions. And these are regularly arranged in a giant lattice. And these positive ions are surrounded by a sea of delocalized electrons, as we can see. The word delocalized meaning they're not fixed in one position. Having said that, although these electrons are considered delocalized, they're not really moving anywhere. They're not fixed in one position, but they're not really moving anywhere. As soon as you apply a force to these electrons, like so, as soon as these electrons experience a force, their motion and their movement changes. These electrons are no longer circling the positive ions. They're flowing around and between them. So remember, if it's white, you should write. When a force is applied, the electrons are now able to flow. The rate of flow of these electrons is called current. This essentially means how fast electrons are flowing through a material. The force that's pushing these electrons through the wire is called voltage. It's also called the electromotive force, or EMF. Let's look at current in a bit more detail. On the left here, we have an animation of a river, and this river is flowing relatively quickly. This means that this river has a high current. Meaning it's flowing quickly. The current in a river can be defined as the rate of flow of water, which essentially means how much water flows in 1 second. In a circuit, however, it's very similar but slightly different. The current in a circuit is the rate of flow of charge. In this case, the charge is electrons. So just like the river, it's how much charge flows in 1 second. Let's take a look at an example in a circuit. So at the moment, the negative charge in this metal wire, meaning the electrons, they aren't moving. Similar to the normal metallic bonding we looked at earlier. But as soon as we close this switch, this battery here is going to push the charges around this circuit. Like so. We can see charge flowing through this wire, flowing through the bulb, back through the wire, through the switch, and back towards the battery. And this process goes on and on. So, our definition for current is a rate of flow of charge. And this can be represented by this equation. Current is represented by the symbol I. Charge is represented by capital Q. And time is represented by a lowercase t. So this is the word equation. This is the symbol equation. And we also need to look at the units. Time, as we all know, is measured in seconds. Charge is actually measured in a quantity known as coulombs, a capital C. And current is measured in amperes or amps. We also need to note that current is measured using an ammeter. This looks a little something like this, but in a circuit, we represent an ammeter using a capital A and a circle, like so. Let's have a go at practicing this equation. A charge of 1.25 coulombs flows in a period of 0.63 seconds. What is the current? This is a fairly simple question, so have a go first. The first step to work this out is to write the equation. Current is equal to charge divided by time. Now we simply substitute into our equation. Our charge is 1.25 coulombs, and our time is 0.63 seconds. We don't know our current, that's what we're meant to work out, so I'll leave that as I. We can simply put this into our calculator, and our current value is 1.98 amperes, or amps. This is a fairly simple one. Let's try another. In this question, we have a charge of 103 coulombs flowing in a period of 2 hours, and we need to calculate the current. Pause the video and have a go at first. So in this question, there's a classic mistake that a lot of people make. Let's see if you made it. The first step to answer this question is to write the equation. And then we're going to substitute our values from the question into it. Our value for charge is 103 coulombs, and our value for time is 2 hours. As we noted before, time must be measured in seconds. Therefore, we need to convert 2 hours into seconds. First, let's consider 1 minute. 1 minute has 60 seconds, and 1 hour is equal to 60 minutes. So 60 minutes is 60 times 60 seconds, which is equal to 3,600. Therefore, 2 hours is 120 minutes, which is equal to 7,200 seconds. So let's substitute that into our equation. 103 coulombs divided by 7,200 seconds. We can simply add that into our calculator and get our answer of 0.014 amperes. Let's try another. A current of 12 amps flows in a period of 10 seconds. What is the charge? Have a go on your own first. Okay, so once again, current in this case is 12 amps. Our charge is unknown, so I'll leave that as Q, and our time is 10 seconds. In this case, we need to rearrange our equation or do the inverse to find our answer. And we're going to multiply both sides by 10 seconds. Okay, so we'll get 12 amps times 10 seconds, which is equal to Q. Substitute that into our or add that into our calculator rather, and we'll find that Q is equal to 120 coulombs. That's it.